Section 9.4 is factoring to solve quadratic equations. I can solve quadratic equations by factoring. Big ideas here. Some quadratic equations can be solved using the zero product property. Sometimes it's useful to write a quadratic equation in standard form before solving. If we look at the take note, please, on page 568, here it's our zero product property. And what this says is that the only way we can multiply to zero is if one of our factors is zero. So we can take our factors, set them equal to 0, and solve. And whatever value we get for our x's there would be the only values that would make that statement true. Because again, the only way we can multiply to 0 is if one of our factors, or the other, or sometimes both, are 0. So using that idea here in example 1, we're going to find the solutions of the equation. Here we have an equation in factored form, which means we have things that are multiplied together. The only way this is going to be true is if one of our factors or the other is 0. That's the only way that we can multiply to 0. So 4t plus 1 could be 0, or t minus 2 could be 0. That's the only way that we can multiply to 0, is if one of the things we're multiplying is 0. And now we just solve these like we've been doing all year long. Subtract 1 to get rid of our plus 1. Divide by 4 to get rid of our 4. And t equals negative 1/4. Or add 2 to get t by itself. And t equals 2. So 2 options here. To check them, we'd plug them back in and make sure that it gives us 0. And both of these will. Again, here we have things that are multiplying together to get to 0. So our zero product property says the only way that this can be true is if one of our factors is 0, or our other factor is 0, or sometimes both if they happen to be the same factor. So if I subtract here to figure out what x equals negative 1, remember anytime it says solutions, we're looking for what value of x, or what value of our variable, and 5. So x could be negative 1, or x could be 5. Same idea here in B. Zero product property says the only way that we can multiply to 0 is if one of our factors or the other is 0. I subtract 3 and divide by 2. And in my second one, I'm going to add 4. So here, x could be negative 3/2, or x could be 4. 2y plus 1 is one of my factors. It could be 0, or my second factor is y plus 14, could be 0. And again, that's the only way we multiply to 14 is if one of our factors, or the other, or both are 0. So here I'm going to subtract 1 and divide by 2. Here, subtract 14, and y equals negative 14. And those are my options here of things that I could plug in for my variable that would make this statement true. Last one here. Again, in order to multiply to 0, one of my factors has to be 0, or my other factor has to be 0. So we take our things that are being multiplied together and set them equal to 0. And solve. We get rid of any adding or subtracting first, and then any multiplying or dividing. Adding or subtracting first, and then any multiplying or dividing. In example 2 here, we have a quadratic function equation here that's in standard form instead of factored form. So here we're not multiplying to 0, we're adding to 0. And that makes it a little bit trickier because we have a lot more options. But if I can rewrite this in terms of factors, which are things we multiply together, then I can use my zero product property. So here, I'm going to multiply to 15 and add to 8, 5 and 3. Same signs because I found the sum, both positive. So again, all I did was rewrite this here so that I'm multiplying things together. Because once I have factors, okay, the only way that I can multiply to 0 is if one of my factors or my other factor is 0. So we solve for x by adding or subtracting first, and then multiplying or dividing if there is any. So here my options for x are -5 and -3. Now feel free to pause here and give this a try if you'd like. Here we're going to multiply to 14 and subtract to 5. 7 and 2. And because 7 is bigger, it gets a sign in the middle. Our signs are going to be different because we found the difference. So +2 minus 7. And these factors are what I can multiply together, and if I were to FOIL them out, I'd get m squared minus 5m minus 14. They're also equal to 0, so I can use my zero product property here, which says that m minus 7 would have to be 0, or m plus 2 would have to be 0 in order for this to be true. Solve for m by adding or subtracting. And here I get my values, 7 and -2. In b here, we're going to multiply to 20 and subtract to 1. Remember, if there's not a number in front, it's a 1. 5 and 4 here. And because we subtracted, we have different signs. And because 5 is bigger, it gets a sign in the middle. So +5 minus 4. Zero product property here says that we can take each of these factors, because we're multiplying to 0, and one of them has to be 0 in order for that to be true. So we have two options. P could be 4, or P could be -5. Here, our first step when we factor is to check for greatest common factors. I don't have one here, so I'm going to use the swing method. I'm going to swing the 2 to the back as multiplication and rewrite it. A squared minus 15a plus 36 equals 0. Here we're going to multiply to 36 and add to 15, 12 and 3. Since we added and from the sum, our signs are both going to be the same, 12 and 3. Don't forget though that since we changed our original problem by multiplying by 2, now I have to divide by 2. Reduce if we can. If not, we'll swing our denominator in front to be our coefficient. Now, zero product property says the only way we can multiply to 0 is if one of our factors equals 0 or our other factor equals 0. And then solve. Here I'm going to add 6. I can add 3 first, adding or subtracting first, and then multiplying or dividing. So here I get 3/2 or 6. In example 3 here, again, I have this in not factored form. It's kind of standard-ish form, but in order for it to be standard form, guys, we have to have everything on one side. So we're going to get it set equal to 0. Okay, anytime we're dealing with quadratics that have both an x squared and an x term, we're going to get it set equal to 0 in order to solve. So in order to get my 18 to the other side, we do the opposite and subtract. Because now that it's set equal to 0, I can use my zero product property. Greatest common factor here, I don't have one, but we want to check. I'm going to swing the 4. We're going to multiply to 72 and subtract to 21, 24 and 3. Because we subtracted and found the difference, we're going to have different signs. 24 is bigger, so it gets a sign in the middle. Now, I multiplied by 4 when I swung and changed my problem. Now I have to swing it back as division. Okay, if we change our problem, we have to change it back if we're only making the change on one side. We can do any change to both sides and it's fine, but if we're only changing one part of our expression, or of our equation, then we need to make sure we undo that. Now, zero product property says the only way that I can multiply to 0 is if one of my factors is 0 or my other factor is 0, and occasionally both if our factors are the same. And from here we just solve. Add or subtract first, and then multiply or divide. So x could be 6 or x could be -3/4. Now feel free to pause here and give this a try if you'd like. Again, our first step is to try and get it set equal to 0 so that we have all of our factors on this, or all of our terms, sorry, on the same side in standard form, because now I can switch from addition to multiplication. This happens to be a perfect square trinomial, or a perfect square trinomial. X squared is x times x, 49 is 7 times 7. Multiply those two together and double it. Is it 14? Yes. So we take our sign from the middle and square it to get to 0. The other thing we could have done, guys, is we could have multiplied to 49 and added to 14 and had 7 and 7. And this means the same thing, guys. When we take our base times itself, it's the same as squaring it. But what this lets us do here, guys, is x plus 7 equals 0 or x plus 7 equals 0. And since these are the same factors, we're going to get the same solution. And this is why I say, when I talk about the zero product property, that one of our factors has to be 0 or the other or both. Here we have the same factor. They both got us to be x equals -7. So x equals -7 is our solution. And we just have one here. In example 4, we're constructing a frame for the rectangular photo shown on page 570. Here, this is 17 inches by 11 inches. And our frame is the same width all the way around. So each of these are x. We don't know what that width is, but we know it's all the same. We want to know if the total area of the frame and photo is 315 inches squared, what should the outer dimensions of the frame be? So here we are looking for total area, and that's length times width. My area here is 315. My length is x plus 17 plus x. So 2x plus 17. My width is x plus 11 plus x, or 2x plus 11. Now, before we can move from one side to the other, we have to simplify each side. So here, I need to multiply, and I'm going to do that by foiling. Firsts, outsides, insides, and lasts. I can combine like terms. And now that both sides are as simple as I can get them, I can get it set equal to 0 to get it in standard form by subtracting the 315. And I subtract that because that needs to go to the other side so that I can get it set equal to 0. Now, here, when we factor, remember our first step is our greatest common factor. The difference here is that now that I have an equation, instead of just factoring that out and multiplying it in front, I can divide it out of my whole expression. And now we're going to multiply to 32 and subtract to 14. And that works, guys, because whatever I do to one side, I can do to both. Plus 16 and minus 2. So zero product property says I can set those both equal to 0 and solve. And here I only have one solution because I can't have a negative 16 inches. So if x is 2 here, we need to figure out our total dimensions. So here I have 2 plus 17 plus 2, so 21 inches, and 2 plus 11 plus 2 by 15 inches. And those are my dimensions. 21 by 15. So get our factors, multiply them out, get it set equal to 0, factor it back down, and go from there.